Hello all. In this video, we will see the problems on potential and potential differences at different types of the charges and different points. So first problem we will take upon potential is a point charge of 1 microcoulomb is at y is equal to minus 3 meter and another point charge of 2 microcoulomb is at y is equal to 3 meter. Find the electric potential at point P of 4, 0, 0, meter. Now, if you identify these points, we know only y coordinates for charges. Y is equal to minus 3 meter and y is equal to plus 3 meter. That's why we will consider other coordinates are 0. Means it lies on only on y axis. Because we don't know what is other coordinates, it is better to consider the charges lies on y axis. One is at minus 3 meter, other one is at plus 3 meter. Okay. Now we have to find what is the potential at point P. Now to find, if you identify these points, this is a 1 microcoulomb charge and this is 2 microcoulomb charge and this is point P 4, 0, 0, that is at x axis. Now to find potential, you know the equation for potential is Q by 4 pi epsilon naught into R. So the potential at point P will be the effect of the potential due to this charge plus potential due to this charge. That is, I will consider potential due to this charge is V1 and I will consider potential this charge is V2. So Vp, that is potential at this point, will be equal to V1 plus V2. So to find V1 and V2, I have to find what is the distance between this point and this charge, and similarly point P and this charge. So I have to find what is R1 and what is R2. To find R1 and R2, I will use the magnitude of vector equation, that is 4 minus 0, x coordinate in this point is 0 and 0 minus of minus 3, that is plus 3 square plus 0 square. I will get R1 distance between this point and this point is 5. Similarly, R2 can be found out by 4 minus 0 plus 0 minus 3 square plus 0 square, so which is also equal to 5. Using the, because the coordinates of this point is minus 0 comma minus 3 comma 0 and coordinate of this point will be 0 comma 3 comma 0. So 0 comma minus 3 comma 0 and coordinates of this, and 0 comma 3 comma 0 is coordinate of this. So using this, I will find distance between these two points. Similarly, these 2 points is using these 2 coordinates. Now we know what is distance between point P and this point and point B and this point, that is R1 and R2, which is equal to, both are equal to 5. Now I will find potential. Now as I told previously, the potential at point P is depends on the potential due to this charge and potential due to this charge. So I will take sum of both the potential produced from both the charges will be equal to total potential at point P. So that is V1 plus V2. V1 is the potential due to this charge and V2 is potential due to this charge. So V1 plus V2. So V1 can be written as Q1 by 4 pi epsilon naught into R1 and V2 can be written as Q2 divided by 4 pi epsilon naught into R2. So Q1 is 1 microcoulomb and Q2 is 2 microcoulomb. So substituting that, it should be 2. So Q2 is 2 microcoulomb. So substituting that, you will get total voltage at the point P is 5.396 kilovolt. So total voltage at the point P is 5.396 kilovolt. So this is the how you will find the potential due to the charge present in different points on point P. What is the effect on that charges on the potential on point P. So next problem we will see is the problem given a infinite number of charges each of q nanocoulomb. So there is an infinite number of charges each of q nanocoulomb are placed along x-axis at x is equal to 1, 2, 4, 8 up to infinity. Find the electric potential and electric field intensity at a point x is equal to 0 due to all the charges. Now there are how many charges are there? There are infinite number of charges are there. So each has a magnitude of q nanocoulomb. So there is an infinite number of charges. Each has a magnitude of q nanocoulomb. And each charge is placed in x-axis. They are placed in x-axis. When x is equal to 1, first charge is placed. When at x is equal to 2, second charge is placed. At x is equal to 4. Similarly, third charge. Similarly, x is equal to 8. Similarly, fourth charge. Similarly, till infinity, infinite number of charges are placed. Now we have to find what is the electric potential due to that all charge, infinite number of charges on x is equal to 0 plane. If we mark on x-axis, you will get like this. So q1, q2, q3 up to q infinity. So at point P, I have to find what is the potential due to all these charges. What is the potential due to these all charges on point P, I have to find. So we know that expression for potential is V is equal to Q by 4 pi epsilon naught into R. So V is equal to Q by 4 pi epsilon naught into R. Now, so first charge, if you consider for first charge, so what is the distance between point P and first charge? So I will take that as R1. So distance between this is 1. So I will take it as 1. So similarly, for second charge, what is the distance between P and second charge? It is 2. So R2 is 2. Similarly, what is the distance between third charge and P is 4. So I take 4. Similarly, the distance between point P and fourth charge is 8. I will take 8. If you observe this 1, 2, 4, 8, we can write these all numbers in terms of 2 to the powers, right? This has 2 to the power 0, this is 2 to the power 1, and this is 4 can be written as 2 to the power 2, and 8 can be written as 2 to the power 3. Now, I'll keep as it is here. Now, what is the total potential at point P due to all these charges can be written as the potential due to this charge, potential due to this charge, plus potential due to this charge. Similarly, infinite till infinity we can add up. So all the potential can be add up and we will get what is the total potential at point P. So we can write the equation for this summation Q by 4 pi epsilon naught into 1 by 2 to the power 0, because the distance between first charge and point P is 2 to the power 0. Distance between second charge and point P is 2 to the power 1. And distance between third charge and point P is 2 to the power 2. And fourth charge is 2 to the power 3. That's why it is 1 by 2 to the power 0 plus 1 by 2 to the power 1 plus 1 by 2 to the power 2 plus 1 by 2 to the power 3 plus up to infinity. Now if you observe this, it is a infinite series, infinite summation series. So I can write, so if your summation series can be written as alpha plus alpha r plus alpha r square plus alpha till alpha r to the power infinity. The sum of this equation can be given by S is equal to alpha divided by 1 minus r. S is equal to alpha divided by 1 minus r. So here alpha is, if you look at this expression and compare with this expression, here alpha is 1 and r is 1 by 2. So r is 1 by 2. So the sum will be, if you substitute alpha and r in this equation, you will get total sum will be equal to 2. So substituting in this 2 in the place of this summation equation, you will get the Vp is equal to q into 10 to the power minus 9 divided by 4 pi into 8.854 into 10 to the power minus 2, that is epsilon naught into 2, which is equal to 7.9754 q volts. So 7.9754 q volts. So this is the potential at point P due to that infinite number of charges. So next part of the question is you have to find what is the electric field intensity also, right? So you know the expression for electric field intensity at a point due to infinite charges at a point can be written as Q by 4 pi epsilon naught into R square into AR cap. Now what is the direction vector? So the direction of the electric field intensity will be from charge to point P. So it will be acting from charge to point P. So it will be opposite to x-axis direction. So we will take that as minus AX cap. So we will take AR is equal to minus AX cap. So direction vector is minus AX cap. So substituting this, you know that this is a summation formula. Again, same summation formula you can substitute and you can obtain summation as 1 by 4 by 3. So you will get after substituting all the values, you will get electric field intensity is minus 11.9833 Q AX cap volt per meter. So this is the value of electric field intensity at point. So this is how you will find electric potential due to infinite charges and electric field intensity due to infinite charges. You can use summation series formula and you can simplify that and you can obtain the results. So next problem we will see, find the potential V on Z axis at a distance Z from origin when uniform line charge rho L in the form of a ring of radius A is placed in the Z is equal to 0 plane. So here we have to find potential on Z axis. The point is given in the Z axis at a distance of Z, and the line charge distribution is now a line charge distribution. What is the potential due to this line charge distribution on this point Z? Now the given the line charge is placed in the form of a circular ring. So in a Z is equal to 0 plane. Z is equal to 0 plane means it is placed in XY plane. So it is placed in XY plane, or so if you take it a circular ring, so where radius and height will come into picture, the radius and height will come into picture in cylindrical coordinate system. So we can consider cylindrical coordinate system, and if you draw a circular ring, okay, if you consider this as a origin, a center of the circular ring, now at height of Z you will be having a point A. At a height of Z you will be having a point A, and here in this circular ring I am considering a small elemental length dl. In this circular ring I am considering small elemental length dl. Now distance between origin to point dl is A. So if I join point A and point P, I will get a right angle triangle. I know what is this side and this side. This is Z and this is A. So this side can be written as R is equal to square root of A square plus Z square using Pythagoras theorem. Now in cylindrical coordinate system, this dl can be written as R dash into d phi. So the elemental area can be written as R dash into d phi. So I can, what is R dash? This radius is A. So A into d phi, because Z, it is a Z is equal to 0 plane. So it is only R dash into d phi, which is equal to A d phi. Now we know what is the distance between them. That is R is equal to A square plus Z square. Now substituting this, you know the equation for potential in his line charge is given by dBA is equal to rho L A, rho L of R dash, rho L into R dash into dl dash divided by 4 pi epsilon naught into R square. So in the place of rho L of R dash, I can substitute rho L into A. R dash is A here. So dl dash is, so rho L of R dash is rho L, and d phi is A d phi. Substituting that, and R is square root of A square plus Z square. So you will get this expression. Now, so to find what is the total potential, we have to integrate with respect to phi. So we have to integrate it with respect to phi. The limits for phi is from 0 to 2 pi. The limits for phi is from 0 to 2 pi. So applying limit and simplifying this, you will get VA is equal to rho L into A divided by 2 epsilon naught into square root of A square plus Z square. This is how we will obtain the expression for the value of potential in a volume charge when it is placed in the manner of circular ring. So in the place of rho L, it is a uniformly charged given, so you can substitute directly rho L, and d phi is A d phi in a cylindrical coordinate system, because it is in a Z is equal to 0 plane. That's why. In next we will see the problems on potential gradient.